I crashed my FPV drone into a fence at 70 km an hour, and in today's video we're going to fix and upgrade it into a new machine which better suits my flying style and needs. Follow my journey from turning this broken budget racing quad into a quality and agile camera drone, perfect for capturing my RC air-to-air footage. The aftermath of the crash was not as bad as I was expecting, just a broken VTX where the antenna connector was ripped off the circuit board. The receiver, although undamaged, I was never that confident in, and I had some connection issues in the past, so I'd planned to just replace the frame, receiver and VTX. But life doesn't always go to plan, and a mistake made me need a new flight controller board and camera too, but I'll get to that later in the video. First, I disassembled the old frame and removed all the electronics. Then I started to assemble the new frame. Once it was mostly done with the standoffs in, I lowered the electronics into place and began to secure the motors with these cool golden titanium coated steel bolts I got. Things were going smoothly with the build, but then something bad happened. I was desoldering the old receiver and the VTX from the flight controller and must have left some solder and jumped some pads, because when I stupidly decided to plug it in without using my smoke stopper, the spirit of Zeus summoned and a flash of sparks and a few of the fuses and other electronic components to Valhalla, frying the board completely. A couple of weeks later, my new flight controller and FPV camera had arrived. I began by installing the squidgy yellow rubber standoffs in the flight controller and ESC boards. Next, I test fit the stack onto the stack bolts to observe the clearances above the top plate and below the ESC board. Now that's what I call perfect fitment. Now it was time to solder. First, I soldered the XT60 battery lead onto the board, making sure to use plenty of flux. Next, I tinned all the ESC motor pads and soldered all the motor wires to them, as well as soldering this capacitor onto the XT60 pads to keep any voltage sags stable. Now that the power system was sorted, it was time to connect the FPV camera. I plugged the connector into this end, then chopped the connector off the other end. I soldered the red wire to a powered pad and bridged these pads to battery voltage because I thought my camera needed 7 volts or more to work, but turns out 5 volts would have worked anyway. Then the yellow wire went to camera in and the black to ground. Next, it was time to mount the video transmitter onto the frame. I took strips of double-sided tape and laid them out as a base. Then I stuck the video transmitter down and secured it with duct tape. It was now time to wire the thing up. The main power wire can take between 7 and 36 volts, so I soldered that to the battery voltage pad and bridged these two pads to get full battery voltage. I put both black grounds to 2 separate ground pads, the green video out to VO, and the IRC tramp telemetry to T2 UART, and that was all done. The next job was to install this Radiomaster RP3 ELRS receiver. These things are super simple to install. The red 5V goes to any 5V pad, ground to ground, then the TX UART goes to RX, and RX to TX, and that's exactly what I did. Then I zip tied the motor wires down, taped the receiver in place, triple checked all the wiring and solder joints, installed the FPV camera, installed the battery pads at the top plate, bolted the top plate down, and finally, after weeks of research and planning and hours of building, the quad was fully assembled. But I didn't know if it would work yet. The only way to find out would be to plug it into the battery with a smoke stopper, of course, and hope nothing set on fire. Well, let's see what happens. Amazing. But we still have some setup to do on the computer before it's ready to fly, so let's get started on that. So I powered on the quad, waited for receiver to enter Wi-Fi mode, and flashed the receiver to ELRS version 4 to match my Radiomaster micro module. So that was the receiver all done. Then I plugged the quad's flight controller into my computer, connected via Betaflight, enabled UART 1 for my receiver, and confirmed the quad bound to my transmitter OK. Next I set my arm and mode switches, set them up in Betaflight, and then I wanted to quickly test the motors, and I found out they weren't spinning the right way. On my quad running props in, this means the top left and the bottom right motors should turn clockwise, whilst the top right and bottom left ones should turn counterclockwise. Fortunately, it's easy to change the direction of each motor using the Betaflight motor wizard, which I did. Next, I downloaded the VTX tables for my video transmitter from GepRC's website and copy and pasted them in. A quick test after selecting the right channel on my goggles confirmed it was all working okay, and after testing the arming switch was all working, and after changing a few settings following one of Joshua Bardwell's setup guides and ensuring there was a default tune on the quad, it was finally ready to go and test fly. I can't tell you how satisfied I was feeling at this moment.